Awesome. All right. Thank you, everyone, for hanging on and coming to the meetup. My name is Franco Patano. I am a lead product specialist at Databricks, but I kind of focus on strategic data and AI advising at Databricks because it's more than just a single product or solution that folks need to get done. But a little bit about me before we dive in. My background is actually ETL, data warehousing, and business intelligence. I kind of grew up from playing around with Excel and VBA, and then used more and crazier tools since then. I grew up in the Chicagoland area. I always dreamed about joining a startup, and then along came this Spark and Delta things, and I kind of really liked what Databricks was doing, and then I kind of joined them. And now I kind of help other folks understand those things. I really like time travel fiction. I make pizza from scratch ever since the pandemic. And I have some really interesting thoughts on the most epic films of all time. And, I always feel like data warehousing has always been a little limiting, and I've kind of been trying to figure out what we can do to really scratch the surface or really get beyond the tools of the past. For those of you who don't know who Databricks is, we're the original creators of the open source projects Delta Lake, which is a table format for data lakes, MLflow, which is a machine learning lifecycle and experimentation management system. And then also everybody knows Apache Spark. We have grown a lot over the years, and now that we're the inventor of this lakehouse concept, unifying the data lake and the warehouse worlds. And then now that we've always been doing AI before LLMs kind of broke onto the scene. NLP has been around for a lot longer, but now that generative AI has broken out, we're kind of pioneering the Gen AI revolution. We think that the winners in every industry will be data and AI companies. What we see is right now everyone is focusing on the AI, but they forget that the thing that actually makes AI work is data. And you have to have good, clean, quality data. And this often becomes a real struggle because often how you manage the data and governance platforms is separate. Privacy and controls are kind of really hard to manage. And then you're often dependent upon really technical staff in order to get all of these components to work together. Originally, we saw a lot of these problems organizations were having, and we saw that the data lake was great, but it needed help in order to actually be useful to organizations. And so we created a unified storage kind of layer. This is Delta Lake, which is the open source project. And then we realized that you can't just have a good table format, but you have to have a good unified security, governance, and catalog to manage all that data. And then you can do all these different use cases that we want to do, like data science and machine learning and AI. And then you kind of have to have ETL or real-time analytics in order to feed those models. And then orchestration is how you kind of make all these things happen, how you orchestrate them. And then everyone's going to need to be able to report on all of these different data capabilities. So you'll need data warehousing. In 2020, we kind of came out with this capability, the lakehouse. And today we're seeing that it's being largely adopted by organizations globally. But when AI kind of came out last year, when GPT really kind of broke the mold with these LLMs, AI has been around for a long time. It's actually been around since like the algorithms have been around since the 50s. But we now see that organizations want to build on top of the lakehouse, and they want to do generative AI. And we believe it's not just chatbots that are going to deliver value to organizations worldwide. You have to actually build the AI into the systems. And it's not just LLMs, it's kind of all of the different types of techniques. And this is kind of what we're building, or we think will be the foundation of how organizations will want to build these types of solutions. You're going to need that unified catalog to be able to know where all your data assets are. You're going to need to have all of that data in a really optimized format on open data lakes in order to leverage them. And then the AI can be built into the actual tools that people use. So if you have SQL analysts, we have text-to-SQL algorithms. For orchestration, there are ways that AI can actually help optimize the whole orchestration pattern. And then ETL can be greatly enhanced from essentially embedding AI into it, whether it's data quality or pipeline management. And finally, you're going to want to have to build all of these different solutions on top of your pipelines. And this is where you want to, create, tune, and even serve your own LLMs at scale. So let's kind of take a look into how organizations struggle with these capabilities. What we've noticed is that every organization, and this is like between verticals, like specific types of industries, and even inside specific companies, they all kind of have their own jargon that they use. And it actually is pretty confusing for an LLM to understand how to do anything. So for example, like we would ask how many DBUs were there in Europe last quarter, but a DBU has many different interpretations. So how is the LLM supposed to understand what's going on? And we think that it's context. You need to have more context around the actual data itself. And this is where you have to actually leverage all of the metadata in the platform itself in order so it can understand what people are asking it. And this is kind of what we are kind of leading the charge with Databricks IQ. Essentially, if we feed the metadata in the catalog along with all the other metadata that the platform has, the LLM or the model should be significantly smarter because it's contextually aware of what the user is asking it. And this is kind of what that looks like. So for example, we embed this type of technology into the search. So the search is more context aware. So when you're searching, it's not just going to give you plain text answers, or like it's not going to search with plain text. It's actually going to try to understand contextually what you're asking for and then give it to you. So for example, here, Nephos is what we call serverless internally. So it understood that serverless was really Nephos. And then over here, we see that if users need to generate the SQL code for text to SQL via the assistant, sometimes they might use different words or different terminologies than exist in the metadata. And then the assistant can actually understand and interpret that and generate code that actually works versus what it thinks it will work. And this is kind of a brand new piece of innovation that has been worked on at Databricks internally. Essentially, our leadership gave an engineering team carte blanche to start from scratch. Don't take any of the debt that exists in Databricks and kind of start from scratch. How would you design a system to get insights out of data from scratch? And we codenamed this Genie. The real name is going to be something else. The two hardest problems in computer science is cache invalidation and naming things. So don't get hung up on the name. But we think that essentially users will want to converse with Genie just like they would the analyst or the data person that they want to get insights out of. And that's what this is. It's kind of, we call them data rooms. Essentially, you tell it what data that you want to look at, and then you use your natural language to kind of understand or ask your questions, and then it's able to make the queries on its own, and then even visualize that for you. So in order to actually have a really intelligent platform, it's more than just putting an LLM in the platform or building an assistant into it. We actually are thinking about how we can use AI to make the platform better. One of these is, how do you manage the data that exists in the data lake for that feeds all of the models and the LLMs? And essentially, doing this is very complex. You have to have teams of engineers that understand all of the different capabilities that are going on with the data. And then, do you partition? Do you Z-order? Do you do all these different optimizations? And what file sizes do you choose? Essentially, we started applying AI, ML to these problems. And what we found was that we got significantly better performance without having to have a team of engineers think about these things and learn about these things and actually implement them. And so now we basically have this model that tunes all of these different factors inside of our platform. Then, you have to have not just a good governance catalog or a catalog, you have to have tools built into it so that the users can actually use this. And this can be, that search, the super search that I like to call it, actually help you document the catalog itself and document the metadata, automated lineage and observability, and actually sharing the models itself. And so this is kind of what that looks like. We saw a little bit of this earlier, but essentially users can try different things like different search criteria and not get what they want. But an LLM or an AI-powered knowledge engine could actually understand what they want to give them their answer. Then we can actually use LLMs to understand the contextual information of what is in a table, and that help you actually generate documentation. Documentation is one of the hardest things in a data platform, and you actually need that in order to power the search. So these two things actually work really well together. The AI-generated documentation builds the context on the tables, and it actually boosts the super search. So we're finding that these two things work really, really well together. Then one of the other hardest problems in data platforms is, how did this data get here? Traditionally, it's really hard to track lineage in other systems. It's very manual. Here, we've automated lineage for all workloads. And essentially, you can track exactly down to the column level and expression level what went where. And this isn't just the reports or models, it's reports and models. Because a lot of times you might have to report or go to a regulator about, how did this model produce this answer, and how did this data get into this report? And with the automated lineage, you can absolutely report and have that information at your fingertips. And then when the catalog actually understands what's going on in the system and it has proper system tables, you can then use AI to do predictive monitoring and observability. So a lot of times in the cloud, what we find is that customers are shocked by their bills, and they kind of get confused, like, how did this even happen? And so what we can do is actually apply these machine learning algorithms to their consumption and help them understand and forecast what their consumption would look like. And we can even build automated table data monitoring capabilities. So essentially, we can monitor the data and do all the different statistics on the data inside the tables, so that we monitor actually what data is looking like. Because skew is a really big problem with models, and with table monitoring, you could actually monitor the data before it goes into the models to make sure that you don't introduce any type of bias or skew into the machine learning models. And then, you're going to need to report on all of these different things that's going on in the data platform. And this is where our Databricks SQL, or our warehouse product, comes into play. Essentially, we've applied machine learning AI techniques to the actual operations of the warehouse. And we're able to have auto-tuning techniques that essentially make queries faster without the users having to mess around with configurations. We're able to apply machine learning techniques to how the warehouse manages itself, given all of the different workloads that are coming in. And we find that it's able to essentially fully utilize without oversubscribing or undersubscribing the warehouse, which essentially maximizes utilization, which is really what every customer wants. They want to make sure they're getting the value for what they spend in the cloud. And then we essentially, one of the hardest problems in performance for queries is, how do you do indexing, or how do you make sure that you do different optimizations so that queries perform very fast? Other vendors make you pay for an optimization service. What we've done is we've created this ML capability, or we call predictive IO, that actually gives you index-like performance without having to pay for it. And people usually generally really appreciate that type of capability. And so inside of Databricks SQL, we have the assistant built right in. So it'll help you, a lot of times this is really helpful for docs. Instead of having to go back and forth between the docs page and the actual application, we find, like, you can ask it, what parameters do I need for this function? Or write me the SQL code on how to do this. Or diagnose my query error. And it can write that in there, kind of diagnose all these different things and help you along your way so that you're not wasting time trying to figure out what's going on. And it makes users generally much more capable to get their job done. And then we have the orchestration platform that we call workflows. Essentially, workflows is how you orchestrate all of the different tasks. So generally, you'll have to ingest data, prepare data, model data, serve data, build models. There's a whole life cycle around machine learning, and then actually publish them. And workflows is how we do that at Databricks. But essentially, what we find is that it's very complicated to actually get efficient and capable orchestration. And what we've done is we've applied automation and machine learning to these capabilities so that we can get better performance out of these orchestrators versus having to have things manual and inefficient. And then Delta Live Tables is our ETL service on Databricks. Essentially, it has Delta Lake built into it, but it enhances it to have better capabilities for orchestrating massive amounts of pipelines. Essentially, this will help automate streaming ingestion or batch ingestion and helps you, solve a lot of these complexity and cost problems. Essentially, it can ingest data from various different sources, prepare data through what we call the bronze, silver, gold pattern. Essentially, you do all the transformations and you prepare it for consumption. And this is key to machine learning data because essentially you have to have good, clean, recent data for machine learning models. And Delta Live Tables is essentially how we get all that data ready for consumption for either the analytics or the machine learning models and AI. And we also use AI to actually make the pipelines themselves more efficient by actually understanding, should it be scaling up, scaling out? Should it be doing different things in order to get better performance? And this is kind of what that looks like for ETL. You can use the assistant itself to help you generate code. So you can spend less time in documentation and more time and thinking about things or researching things and more time actually building production grade code for your pipelines. There's a question about running applications on CPUs or GPUs. Our platform runs on both. Generally, you'll want to use CPUs for analytical tasks or ETL, and then GPUs for machine learning or any type of vision or LLM preparation. But we kind of support both. There's actually some interesting things that we're researching right now about using GPU acceleration for SQL, but that's a little further down the pipe. And essentially, the results of intelligent and optimized transformations is that you get much better performance for much lower cost. And this, we run a significant amount of benchmarks at Databricks. Two of the most common are TPCDS for query serving and TPCDI for ETL. And we've kind of set the record on price performance on both of these capabilities. And there's another benchmark I'm trying to get the team to build out. It's called TPC AI. It actually is various forms of machine learning and AI capabilities. So more to come on that front, but we think that we give the best price performance for all of these capabilities. Now, once you have all of the data cleaned, ready to go, now we can get into the different types of AI machine learning algorithms that we have in the platform. And here we have a lot of different options. You can build your own custom models. You can serve models that already exist. You can use RAG. We actually recommend RAG in order to decrease hallucinations. But you have an end-to-end platform. Essentially, what we see as the primitives that you need in order to build good models is you have to have a good vector search and a feature store. Vector search for LLMs, but feature store for traditional machine learning algorithms. And then you have all of these different types of modeling capabilities. We now have a RAG studio built inside the platform. We also have been working on AutoML for foundational models and even fine-tuning foundational models. And then once you kind of model all that data, you need to get it in production. And here's where we have a serving layer to serve all those models, even an AI gateway to help you manage maybe models that you have in different places. And then how do you monitor all that? And this is kind of what we see as the three main ways that organizations are kind of thinking about how they use their data for these new use cases. You start with RAG. You have RAG, and this is what we really recommend because you can hot swap the model, and your contextual data kind of stays separate. Fine-tuning models is expensive if you have the capability to do it, but we have capabilities in the platform to make it efficient, and you can go ahead and pre-train your own model. And this is kind of the most custom way to build this. AutoML for foundational models, we have kind of earlier this year, we made an acquisition of Mosaic ML. Mosaic builds MPT, which is similar to GPT, but it's Mosaic's version. But you don't have to use that. We also support Falcon, Llama, any of the different types of models. But what we see is you need to bring a sufficient amount of clean quality data sets in order to do that. And then we have the capability to do AutoML to build your own models, and then you can serve those. For fine tuning, we find, again, you need good quality, clean data. And this is where Delta Lake comes in and the ETL patterns. And then essentially what we find is you want to choose a model, but you can have all different types of capabilities for these models. You can use Llama, MPT, you can use text embeddings, transcription services, code generation services, and image generation services. And what we supply is a model gallery where you can choose all these different types of models, and then you can serve them. Or you can take your own model and model your own weights. We kind of give you a lot of different options. The MLflow's AI gateway is actually pretty amazing. We heard yesterday that Google has now strike back with their model, with their new model. There's a lot of marketing about it. GPT, we're still waiting to hear what they've got next. I find it interesting that it's taking so long. But essentially, we give you the capabilities to look at all the different options and actually evaluate what responses you're getting out from all of these different types of models so that you can make the best choices for your needs at your organization. We really want to help you understand, have a common way to evaluate all of the different options and even control rate limiting. So a lot of these models have different costs. And so sometimes you want to route them based upon what's going on, how much you're consuming. And MLflow AI Gateway helps you manage all of those different capabilities. For model serving, there's a few different ways that this is supported. We have, traditional machine learning model serving where you have, a model that you would build either with Databricks or you can pick it off of Hugging Face. But essentially, you can integrate those with the feature store or the vector store. And if you want to do CPU or GPU, we have capabilities for those. You can also build your own foundational models and then serve those foundational models via Databricks. Or you can have external models where you would want to serve when you want to hit them with the MLflow AI Gateway, and then you can kind of monitor the payloads and log everything so you understand what's going on and make good choices while the models are running. And that is essentially the Databricks data intelligence platform. We think that AI is not a solution in a silo. AI requires good, clean, quality data. It also requires efficient pipelines in order to feed those models. And even if you're not feeding models and you're feeding a vector store, you still need good quality data in order to do that. And then how you want to kind of fit different components and build those things, you should be free to do that. And with that, I'll take a look at the questions. So Does Databricks AI give suggestions for feature engineering? So one of the core capabilities of Apache Spark is feature engineering. So we have, the capabilities inside of Spark, or you can use any open source tool within the platform to get that job done. But then we also have a feature store built in. Right now, we have an offline feature store that's backed by Delta, but we are currently previewing an online feature store that will kind of just fit right in. In Databricks AutoML, can you configure the hyperparameters, search space, and configure the regularization, including dropout? So it's very early days for AutoML. I would say some of those capabilities might exist, but I don't know if everything does. I think hyperparameters are there, but I am not an AI expert down to that level of learning about regularization. But definitely, if you're interested, we can reach out and get those answers for you. Do you hook into a third-party vector search engine, or do you have your own? We built our own. Earlier this year, we acquired, I forgot what the name was, Rubicon. They're building out our own vector store. You're welcome. How do you go about estimating workforce requirements for AI ML deployment? See if they use a Databricks model. This is a good question. So what I'm seeing kind of arise right now, a lot of organizations are still figuring this stuff out. So no one really has the entire thing figured out yet. And everything is changing so fast that even if you think you have it figured out, things change. But what we see is that you should have a good ML ops lifecycle, and this is where ML flow comes in. But then the roles themselves, a good ML engineer or LLM engineer or an ops engineer, we are seeing a lot of these new types of roles emerge. Really, what I would say is the skills are more important than the specific role, but good skills in understanding how the tech works, but then also inside of the organization. Yes, Databricks does support real-time. Spark streaming is the underpinnings of our streaming analytics. But on top of that, we built Delta Live Tables. Delta Live Tables is a end-to-end streaming first platform where you can create different types of streaming patterns. And then you can essentially build pipelines to stream that data, do data quality analysis on that data, and make sure that good, clean, quality data gets into your models, and you can stream that as well.